Hello, and welcome back to the Sleep Lab. Tonight we're going to drift through the strange, private theater that plays quietly inside your own mind every single night, the dreams you may or may not remember by morning. Built from fragments of memory, emotion, and imagination, your sleeping brain assembles with a kind of quiet, tireless creativity. Why a particular face appears, why an old house returns again and again, why some nights feel like nothing at all and others feel like an entire lifetime, all of it traces back to real, careful science, gathered slowly across decades of studying the sleeping mind. Tonight we're going to move through 100 small, gentle facts about exactly why you dream what you dream, one detail after another, offered slowly enough to simply drift past you the way a dream itself tends to. Nothing tonight needs to be remembered. Just let it settle softly, and carry you onward toward whatever your own mind has already, quietly begun preparing for tonight. If this kind of journey is worth your time, a like, a subscribe, or a thought left below helps this small lab keep its lights on for other sleepy minds finding their way here. But for now, there is nothing you need to do except settle in, let your body grow heavy, and let 100 small truths about dreaming drift gently over you instead. Let's begin. 1. Nearly everyone dreams multiple times each night, even those who insist they never dream at all, simply because most dream content fades from memory within minutes of waking. 2. Dreams occur throughout every stage of sleep, though the most vivid, story-like dreams are most closely associated with REM sleep, the stage marked by rapid eye movement beneath closed lids. 3. The word REM was first coined in 1953, when researchers Eugene Aserinsky and Nathaniel Kleitman noticed sleeping subjects' eyes darting rapidly beneath their eyelids at regular intervals throughout the night. 4. A single night's sleep typically includes 4 to 6 separate REM periods, each one growing progressively longer as the night goes on, which is part of why your longest, most vivid dreams often arrive closer to morning. 5. Dream content tends to draw heavily from recent waking experience, a pattern researchers call the continuity hypothesis, meaning the people and places filling your dreams are rarely as random as they feel. 6. Roughly 70% of the people who appear in your dreams are people you already know in waking life, even if their appearance or behavior seems strange or unfamiliar once inside the dream itself. 7. Strangers who appear in dreams are often, according to research, actually composites, faces your brain has quietly assembled from fragments of people glimpsed only briefly during the day. 8. Certain dream themes appear with remarkable consistency across nearly every culture studied, including being chased, falling, and appearing in public without proper clothing. 9. Being chased is one of the most universally reported dream experiences in the world, and researchers connect it directly to the brain's ancient, deeply wired threat processing circuitry. 10. The amygdala, the brain's small, almond-shaped emotional center, becomes significantly more active during REM sleep, often surpassing its usual waking activity levels entirely. 11. This heightened amygdala activity helps explain why dreams so often carry disproportionate emotional intensity, especially fear, compared to the relatively calm, uneventful nature of most ordinary days. 12. Negative emotions appear somewhat more frequently in dream content than positive ones, a pattern researchers believe reflects the brain's evolved tendency to rehearse and process potential threats. 13. The prefrontal cortex, responsible for logical reasoning and careful judgment while awake, becomes notably less active during REM sleep, which helps explain why dream logic so rarely makes sense. 14. This reduced prefrontal activity is part of why bizarre, impossible events, flying, shapeshifting, sudden scene changes, rarely strike the dreamer as strange while the dream is actually happening. 15. Dream amnesia, the tendency to forget even vivid dreams within minutes of waking, is also connected to this same reduced prefrontal activity, which normally helps encode new memories properly. 16. People who wake up naturally, without an alarm, tend to recall their dreams more often than those jolted suddenly awake, since natural waking allows a gentler transition back into full memory encoding. 17. Keeping a notebook beside the bed and writing down dream fragments immediately upon waking has been shown to meaningfully improve a person's overall dream recall over time. 18. Some people report dreaming in vivid color, while others report black and white dreams almost entirely, a difference researchers have partly linked to how much black and white television a person watched in childhood. 19. Studies comparing older and younger generations have found that people who grew up with black and white television report black and white dreams considerably more often than those raised entirely on color screens. 20. The hippocampus, the brain's memory-forming center, plays an active role in supplying dreams with raw material, weaving recent experiences together with older, more established memories. 21. Researchers studying rodent brain activity have found that the same neural firing patterns recorded while an animal navigates a maze while awake are later replayed during sleep, a phenomenon called hippocampal replay. 22. This replay happens at a considerably faster pace during sleep than the original waking experience, suggesting the sleeping brain reviews the day's events with remarkable, accelerated efficiency. 23. Elements from your actual day are more likely to appear in that same night's dreams, a pattern researchers call the day residue effect, first described by Sigmund Freud more than a century ago. 24. Interestingly, memories from about a week earlier also show up in dreams more often than memories from the days in between, a delayed pattern researchers call the dream lag effect. 25. This dream-lag pattern suggests memory consolidation during sleep may unfold gradually across several nights, rather than being fully completed in just a single night's rest. 26. Sigmund Freud famously proposed that dreams represent disguised, symbolic wish fulfillment, though modern neuroscience has moved considerably away from this specific, purely psychoanalytic interpretation. 27. A more influential modern model, called activation synthesis theory, proposes that dreams arise largely from the brain's attempt to make coherent narrative sense of essentially random neural signals originating deep in the brainstem. 28. This theory was first proposed by researchers J. Allen Hobson and Robert McCarley in the 1970s, based on their careful study of exactly which brain structures activate at the very onset of REM sleep. 29. The pons, a small structure within the brainstem, appears to function almost like dreaming's ignition switch, triggering the broader cascade of brain activity associated with REM sleep. 30. We've reached the first third of tonight's list. Somewhere, right now, someone is quietly, gently dreaming. 31. The visual cortex, responsible for processing sight while awake, becomes measurably active during dreaming, generating vivid imagery despite the eyes being fully closed and receiving no actual outside light. 32. People blind since birth typically do not experience visual imagery in their dreams at all, since their visual cortex never developed through genuine visual experience in the first place. 33. People who lost their sight later in life, after their visual cortex had already matured, generally continue to experience visual dream imagery for the rest of their lives. 34. The same pattern holds true for other senses, and deaf individuals typically report dreams with little or no auditory content, depending on when their hearing loss actually occurred. 35. Nightmares, distinct from ordinary unpleasant dreams, are typically defined as dreams disturbing enough to actually wake the sleeper, often accompanied by genuine physical fear. 36. Children experience nightmares more frequently than adults on average, a pattern researchers connect to still developing emotional regulation and a still maturing prefrontal cortex. 37. Recurring nightmares, in which the same distressing dream content repeats across multiple nights or even years, are treatable through a therapy called imagery rehearsal, involving consciously rewriting the dream's ending while awake. 38. Sleep paralysis, a genuinely different phenomenon from nightmares, occurs when a person becomes consciously aware while the body's natural REM sleep muscle paralysis has not yet fully lifted. 39. This temporary paralysis, called REM atonia, exists specifically to prevent a sleeper from physically acting out their own dreams, a protective mechanism generated deep within the brainstem. 40. In rare cases, this protective mechanism fails, a condition called REM sleep behavior disorder, in which a person can be observed genuinely, physically moving in step with their own dream content. 41. Lucid dreaming, the experience of becoming aware that you are dreaming while the dream itself continues, is estimated to occur at least occasionally in more than half of all people. 42. Neuroimaging studies have found that lucid dreaming is associated with increased activity in the prefrontal cortex, the very same region ordinarily quieted during typical, non-lucid REM sleep. 43. Some researchers have successfully trained volunteers to increase their lucid dreaming frequency through repeated reality testing exercises practiced consistently during ordinary waking hours. 44. Certain lucid dreamers have even learned to communicate with researchers in real time, using prearranged eye movement signals detectable through the very same rapid eye movements that define REM sleep. 45. Dreams appear to serve a genuine role in emotional processing, with several studies finding that a difficult emotional experience feels measurably less distressing the day after a full, uninterrupted night of REM sleep. 46. The amygdala's response to emotionally charged images has been found to weaken somewhat after a night of quality sleep, but only when that sleep included a healthy, undisturbed amount of REM specifically. 47. This has led some researchers to describe REM sleep as a kind of overnight, built-in emotional therapy, gently reprocessing the sharper edges off a difficult day. 48. Sleeping on a difficult problem has genuine scientific support, particularly for creative, insight-based problems requiring a fresh reframing rather than straightforward calculation. 49. A well-known 2004 study found that participants who slept between learning a complex puzzle and attempting to solve it were roughly twice as likely to discover a hidden shortcut compared to those who stayed awake. 50. We've reached the halfway point of tonight's list. Somewhere, gently, a difficult problem is being quietly reorganized inside someone's sleeping, dreaming mind. 51. Pregnant women frequently report unusually vivid or strange dreams, a pattern researchers connect to hormonal shifts along with more frequent nighttime waking, which naturally improves dream recall. 52. Certain medications, particularly those affecting neurotransmitter levels, can noticeably alter dream vividness and frequency, sometimes producing unusually intense or memorable dream content as a side effect. 53. Alcohol tends to suppress REM sleep earlier in the night, followed by a rebound of unusually intense REM sleep later on, which is part of why heavy drinking is often followed by disturbingly vivid dreams. 54. Stopping certain medications, or discontinuing alcohol after regular use, can similarly trigger a temporary surge in REM sleep, sometimes producing unusually vivid dreams for several nights afterward. 55. Fever has long been associated with strange, often unsettling dreams, and some researchers believe elevated body temperature may directly affect the brain regions responsible for dream generation. 56. External stimuli occurring during sleep, including sounds, temperature, or physical sensation, can sometimes become gently woven directly into ongoing dream content without ever waking the sleeper. 57. In one well-known experiment, researchers sprayed a light mist of water on sleeping participants, and many later reported dreams involving rain, water, or gentle dripping sounds. 58. This phenomenon, sometimes called dream incorporation, suggests the sleeping brain remains at least partially, quietly aware of its immediate physical surroundings even while fully engaged in an unrelated dream narrative. 59. Some studies have found that people can be gently cued to dream about specific content using carefully timed scents or sounds associated with material learned earlier while awake, a technique called targeted memory reactivation. 60. This technique, still an active area of research, has shown genuine promise for strengthening memory consolidation overnight, though it works only on material already learned, never on entirely new information. 61. Dreaming appears to be evolutionarily ancient, and researchers studying brain activity in other mammals, including cats and rodents, have found sleep patterns closely resembling human REM sleep. 62. Some birds also show REM-like sleep patterns, though considerably shorter and less frequent than mammals, suggesting the biological roots of dreaming stretch back further than mammals alone. 63. The specific evolutionary purpose of dreaming remains genuinely debated among researchers, with proposed theories ranging from memory consolidation to emotional regulation to simple, incidental brain activity requiring no deeper purpose at all. 64. One influential theory, called the threat simulation theory, proposes that dreaming, and nightmares specifically, evolved as a kind of safe, low-stakes rehearsal space for recognizing and responding to genuine danger. 65. Supporting this theory, studies have found that people living through genuinely dangerous or threatening circumstances tend to report a higher proportion of threat-related dream content compared to those living in safer, calmer conditions. 66. Children's dreams tend to feature simpler narratives and more animal characters compared to adult dreams, gradually shifting toward more complex, socially detailed content as they grow older. 67. Older adults report somewhat less frequent dream recall on average compared to younger adults, a pattern researchers connect partly to natural, gradual changes in sleep architecture that occur with age. 68. Some people report almost never dreaming at all, though researchers generally believe this reflects poor dream recall rather than a genuine absence of dreaming itself. 69. Certain rare cases of brain injury have resulted in people losing the ability to dream entirely, offering researchers valuable, if unfortunate, insight into which specific brain regions are truly essential for dream generation. 70. Dreams involving flying are reported relatively commonly across cultures, and some researchers connect this theme to a genuine physiological sensation, the body's own vestibular system responding to the total absence of gravity-related feedback during deep sleep. 71. Falling dreams, similarly common worldwide, sometimes coincide with a hypnic jerk, the sudden muscle twitch many people experience while first drifting off to sleep. 72. Teeth-related dreams, another surprisingly common theme, have been loosely connected by some researchers to actual, unconscious nighttime teeth grinding, called bruxism, occurring during the very same sleep period. 73. 74. Some people experience what researchers call 75. Nested false awakenings, in which a person dreams of waking up multiple times in a row, have been documented in research and can feel genuinely disorienting once the sleeper truly wakes. 76. Some cultures throughout history have treated dreams as messages from ancestors or deities, a belief system called dream oracle tradition, found independently across many entirely unrelated civilizations. 77. Ancient Egyptians kept detailed dream dictionaries, cataloging specific dream symbols and their believed meanings, some fragments of which have survived in written form for thousands of years. 78. Modern scientific research has found little support for the idea that specific dream symbols carry universal, fixed meanings, favoring instead a more personal, context-dependent understanding of dream content. 79. Dream researchers today generally focus less on decoding hidden symbolism and more on understanding the underlying neural processes that generate dream content in the first place. 80. Some researchers have successfully used machine learning algorithms to predict broad categories of dream content directly from brain activity recorded during sleep, a genuinely remarkable, still developing area of research. 81. This research involves first training an algorithm on brain activity recorded while a person views specific images while awake, then applying that same model to interpret brain activity recorded during sleep. 82. While far from literal dream video playback, this research has successfully predicted general dream content categories with meaningfully above-chance accuracy, confirming dreams leave genuine, measurable traces in brain activity. 83. Emotionally significant waking experiences are more likely to appear in dreams than emotionally neutral ones, suggesting the brain prioritizes certain material for overnight processing over other, less significant content. 84. Some therapists use dream content as a starting point for exploring a client's current emotional concerns, not to decode hidden symbols, but to gently open conversation around what the dream might reflect. 85. Dreams about deceased loved ones are reported by a significant portion of people who have experienced loss, and many describe these particular dreams as feeling unusually vivid or comforting compared to ordinary dreams. 86. Some grief researchers view these particular dreams as a natural, healthy part of emotional processing, offering a gentle, imagined space for connection long after a loved one has passed. 87. Dreaming appears to increase in both frequency and vividness during periods of significant life change or stress, possibly reflecting the brain's heightened need to process and integrate new, emotionally significant material. 88. Some studies suggest that people who journal regularly about their waking emotions report somewhat clearer, more coherent dream narratives, possibly because journaling itself supports better overall memory processing. 89. Dream content across different cultures shows both striking similarities, including common universal themes, and genuine differences, often reflecting each culture's particular daily concerns, values, and environment. 90. Researchers studying dream reports from hunter-gatherer societies have found considerably less anxiety-related content compared to reports collected from people living in fast-paced, industrialized settings. 91. Sleep researchers studying this pattern have proposed that modern daily stress may genuinely, measurably shape not just how well we sleep, but the emotional tone of what we dream once we finally do. 92. Naps, particularly those that include REM sleep, can also include genuine dream content, though nap dreams are often shorter and somewhat less narratively elaborate than dreams occurring later in a full night's sleep. 93. The final REM period before natural waking tends to be the longest of the night, which is part of why the dream you remember most clearly is so often the very last one you had. 94. Some researchers believe the specific act of remembering a dream may itself subtly alter or reconstruct it, meaning the dream you recall upon waking may already differ somewhat from the dream as it was actually experienced. 95. Despite decades of research, scientists still do not have a single, fully agreed upon explanation for exactly why we dream, though the accumulated evidence increasingly points toward memory, emotion, and rehearsal all playing genuine roles. 96. What researchers do agree on is that dreaming is not random noise to be dismissed, but a genuine, active product of a remarkably sophisticated, coordinated network of brain structures working together each night. 97. Every dream you have ever had, remembered or forgotten, vivid or faint, was built from the very same raw material, your own memories, your own emotions, quietly rearranged by your own mind. 98. In that sense, no two people have ever truly had the same dream, since no two people carry the exact same lifetime of memory and feeling for a sleeping brain to draw from. 99. Tonight, whatever you happen to dream, will be built the very same way, quietly, carefully, from everything you've lived, felt, and noticed, without you ever needing to ask it to. 100. And perhaps that is the gentlest truth of all, that your own mind has been quietly, faithfully doing this work every single night of your life, and is, even now, getting ready to do it again. We have reached the end of tonight's 100 small truths about dreaming, each one a quiet thread pulled gently from the strange, private theater your own mind builds new every single night. We touched the amygdala's heightened fear and the prefrontal cortex's quiet retreat, the hippocampus supplying memory and the visual cortex conjuring sight from nothing but its own internal activity. We remembered nightmares and lucid dreams, falling dreams and flying dreams, and the quiet, ancient thread connecting dreaming across cultures, centuries, and even species far beyond our own. There is something gently worth carrying from a list built entirely around something so intimate, a reminder that even in sleep, even in the dark, your own mind never really stops quietly, faithfully working on your behalf. If tonight's 100 small truths were worth your time, a like, a subscribe, or a thought left below helps the Sleep Lab stay open for the next curious, sleepy mind who finds their way here. And if you're still awake, there's another story waiting just beyond this one, whenever you're ready for it. But for now, let your own mind begin its quiet, familiar work, gathering tonight's dream from everything you've carried through the day. Let your body grow heavy. Let your breathing slow. Sleep well. And good night.